Hello everyone, welcome back once again. This is Nagaraj SK, Lecturer of Computer Science and Engineering Department, Jain Polytechnic, Belgavi. In this session, I am going to continue with lecture number 39 and 40, and I am going to complete this unit number 4, that is divide and conquer technique. So here I am going to brief you about binary tree traversals and the related properties of binary tree traversals. Before going to understand these one by one binary tree traversals and their properties, let me tell you about what is binary tree. So a binary tree is a finite set of nodes that is either empty or consists of a root, and two disjoint binary trees TL and T are called respectively the left and right subtree of the root. We usually think of a binary tree as a special case of an ordered tree. Since the definition itself divides a binary tree into two smaller structures of the same type, the left subtree and the right subtree, many problems about binary trees can be solved by applying the divide and conquer technique. So, the standard representation of a binary tree looks like this. So, here it is a root and it is the left tree, it is the right subtree, left subtree and right subtree of the root. This is how we can represent the standard representation of a binary tree. So as an example, uh, for binary tree, I am considering here an recursive algorithm for computing the height of a binary tree. So it is a pseudocode here for computing the height of a binary tree, and we have to recall that the height is defined as the length of the longest path from the root to a leaf, and hence it can be computed as the maximum of the heights of the roots left and right subtrees plus 1, and we have to add 1 to account for the extra level of the root. Also we have to note that is convenient to define the height of the empty trees as -1. Thus we have this following recursive algorithm here, that is for computing the height of a binary tree. So it computes recursively the height of a binary tree, and what input we are passing to this height function here is a binary tree, and what output we are going to get is the height of the tree. And if t is equal to null, return -1. T is equal to null, return -1, else return max height t left comma height of tree right plus 1. Then measure the problem's instance size by the number of nodes n of t in a given binary tree t, and the recurrence relation recurrence relation is a of n of t is, that is a of n of t left plus a of n of t right for n of t greater than 0 if a of 0 is equal to 0. So before we solve this recurrence, let us note that one more thing, that addition is not the most frequently executed operation of this algorithm. So what is checking? And this is very typical for binary tree algorithms, that the tree is not empty. For example, for the empty tree, the comparison t equal to null is executed once, but there are no additions, and for a single node tree the comparison and addition numbers are 3 and 1 respectively. It helps in the analysis of tree algorithms to draw the tree's extension by replacing the empty subtrees by special nodes, that is the extra node shown by little squares. I'll be briefing you about that external and internal nodes of the binary tree. So here this is about the algorithm for recursive algorithm for computing the height of a binary tree. So here uh, as I said, the extra nodes shown by little squares are called as external, and the original nodes shown by little circles are called as internals. By definition, the extension of the empty binary tree is a single external node, and it is easy to see that the height algorithm makes exactly one addition for every internal node of the extended tree, and it makes one comparison to check whether the tree is empty for every internal and external node. Therefore, to ascertain the algorithm's efficiency, we need to know how many external nodes an extended binary tree with n internal nodes can have. And after checking and a few similar examples, that is easy to hypothesize that the number of external nodes x is always 1 more than the number of internal nodes n, that is x equal to n plus 1. Then we have the binary tree traversals now. So what is binary tree traversals? So there are three common binary tree traversal orderings. Each one begins at the root. So there are three binary tree traversals options available to us, that is pre-order traversal, in-order traversal, and post-order traversal. So what is pre-order traversal? The current node is processed in the pre-order traversal of for a binary tree. The current node is processed, then the node's left subtree is traversed, and the node's right subtree is traversed. So in the graph, in the tree, first we are going to process the current node, that is root. Current in the sense that is root, that is pre indicates that first, then left subtree, then right subtree of the binary tree. So this is how we are traverse with the help of pre-order traversal. Then in order traversal, that is the node's left subtree is traversed, then the current node itself is processed, then the node's right subtree is traversed. That is, first we are going to process left subtree of the root, then current, that is root node, then right subtree of the root, that is in order traversal. That is left in between left and right we are processing root node, that's why it is in order traversal. Then post order traversal, the node's left subtree is traversed, then the node's right subtree is traversed, and lastly the current node is processed. That is, first we are traversing left, then right subtree we are traversing, then at the end we are traversing the root node, that is post order, first left and right, then at the end we are processing the root node. So that is all about the binary tree traversals orderings. So we'll see these with the help of examples. So we have here first one, binary tree pre-order traversal. So this is the given tree, that is c acts as a root c, then it is having a left subtree and right subtree. So left subtree is f, again f acts as a root for t and k, then again t acts as a root for b and r. So pre-order in the sense, first we are processing root node, then left node, then right node. So what is the pre-order here? So what is the pre-order of this given graph? So first we are processing this root, that is c. So I have written here order c. Then we have to process left subtree of the root node C. So what is the left subtree of this tree is root is F. This we are processing, right? Then again here after this again here we are having the subtrees of this root. So what is the root? T is there. So pre-order, in pre-order again it is having a subtree, that is T. Again T acts as a root, so that we need to process next. Then after that go for left subtree of this node, root node T, then right subtree of this node T, that is R. Then left is over, left part of this F is over, then go for right part of the right subtree of the F root. Then now this completely the left side of this root C is over, then the right subtree of C is, that is G, that will be processed at the end. So this is how this order we are getting here, that is C, F, T, B, R, K and G. This is about pre-order traversal. Then we have in order traversal. So we are having an order here. So how it is processed? In order, first we are processing left. In order says that we have to process the left subtree of the root and root node, then lastly the right subtree of the root. So first we have to process, this is our root, so we have to process this left, right, and this is its right. So first we are going to process the left part of C node. So left part of this root node C is F is there, and again F will be acting as a root for this T and K, and T acts as a root for B and R. So we have to traverse B first, because we have to the left part of this root is T is, that is B. This we are processing. So that is our first sub node of the order. Then after that root we have to process, that is T we are processing here. Then after that right subtree of the root node T, that is R, we processed. Then after that this roots left and right is over, then F's left is processed, then F we need to process. F's left subtree is over, after that root node F, then right node K, then its left is over, that is C root nodes left part is over. Now we have to process this root, then right part of the root node, that finally we are processing G. This is how the in order traversal works. First we have to process left part of the left sub part of the root node and root node, then at the last right part of the subtree, right part of that root node. This is in order traversal of binary tree. Then we have the post order traversal of binary tree. So here also we have here what we have to do, we have to process left subtree of the root node and right subtree of the root node, and finally the root node. So what we have to do here is, this is our root node, and its left we have to process completely. So again f acts as a root for t and k, and t acts as a root for b and r, right? So its left is, t's left is b, we are processing first, then t's right is r, we are processing, then root node we processing, then left is over, then k we are processing right of the f node, then root we are processing, that is f, then left is over, left part of c root node is over, then right part we are processing, that is g we are processing, then the root node, that is c, we are processing finally at the end. So this is how the post order traversal works for binary tree. Then what are the properties of binary tree, right? A tree with n nodes has exactly n minus 1 edges or branches, and in a tree every node except the root has exactly one parent and the root node does not have a parent. Then there is exactly one path connecting any two nodes in a tree. Then the maximum number of nodes in a binary tree of height k is 2k plus 1 minus 1, where k greater than or equal to 0. These all are the properties of binary tree. So let me summarize what we discussed so far. We discussed about the following, that is what is binary tree, we understood, then how to represent and find the height of the binary tree, then binary tree traversals like pre-order, in-order and post-order, then finally the properties of binary tree traversals. So if you are having any doubts in this, please do ask your queries. Thanks for watching.